All right, hello everyone. So today is week 2 of programming training, and as you may know, this is actually a course that we're teaching our own members, and we thought it'd be great to also release a set of videos for anyone who might be interested in FTC programming. All right, so to give another brief introduction about ourselves. We're Wolf Corp Robotics. We're a 5th-year FTC team, and we're a 9th-year first team. And first, an FTC not only is about a robot competition, but also takes into account and celebrates interpersonal skills. So that might be communication, outreach, leadership, those kind of things. And so we're based in Walnut High School. And in 2021, so this past season, we won first place at SPAR Award at the Los Angeles Regional Championship. So this is a training overview. This is week 2. And so the purpose of this course is to cover a high-level overview and fundamental technical knowledge in Java and FTC robot programming. And if you haven't seen our first week's video, you should go check that out. It's also on our YouTube channel. And so today is week 2, and we're doing a Java crash course. And so we'll be having an interactive lecture talking about Java, and it's going to be incorporated with Android Studio and FTC development environment. And this is because Java is what we use to program the robot in FTC programming. And so to give a recap of week 1, what we did was we talked about what programming was and what Java was, and we talked about some key aspects of Java. So object-oriented programming, the JDK, the JRE, the JVM. So that's the Java development kit, the Java runtime environment, and the Java virtual machine. JDK is basically everything you need to run, develop, debug, deploy Java applications. The JRE is within the JDK, and the JRE, the Java runtime environment, is where usually you have library files, and the JVM is included in the Java runtime environment. And the JVM, the Java virtual machine, is where the actual code that you compile and you run, and that's where the actual running happens. And so we also talked about compiler and runtime, so how Java actually is write once, run everywhere kind of a language, and how you have to take your Java code and it has to first be compiled to Java bytecode, and then it can be run on machines. And we also talk about Android Studio, the FTC SDK, and the Control Hub. Android Studio is where we code. FTC SDK is where where FTC gives us the tools to develop programs for the robot, and the Control Hub. Control Hub is something you put on your robot to be able to successfully control things like motors, servos, and even things like a web camera. And so we also talk about libraries and frameworks. So Roadrunner, OpenCV, Vuforia, and TensorFlow. Roadrunner is for kind of really fancy path planning and making advanced trajectories and making a robot be able to, like, say, turn and move while maintaining a certain heading all at the same time. OpenCV is Vuforia and TensorFlow. They're all version detection models. And we also talk about Git. Git is a way to manage your code. It's a version control system. And programming tasks. So what we have to do as a programmer, how we have to make make efficient autonomous with multiple paths. Also teleops that effectively or they make the driver's job easy and makes the controls intuitive. And then finally, we finish it off with a lab on setting up our development environment, and then exploring the FTC SDK, as well as localization systems and some tips to learn more resources. All right, so we'll start off with Android Studio environments. Let's go ahead and open up Android Studio. So I already have it opened, and I actually have some stuff here, but we're gonna go ahead. I'm going to delete all of this first. So we can just ignore that. Let's actually, we'll delete the classes that we made here. This was from the class we had yesterday with just our team. So if you usually close Android Studio, right, you just go to your, if you're on Windows, you probably just search or open up Android Studio, give it a second to load. And we're gonna first pretend that for some reason your project is closed, and you might be wondering, how do I open up my project again? So we'll quickly recap that. So if you want to close your project, if it's already open, you can just click close project here. So file, close project. And you'll usually see this. This might not even be here, so it might look something like this. So what we want to do is just import project. We can click on FTC robot controller master, and you always want to make sure you're opening the right folder, or some things might not work. And so you want to make sure your structure looks like this. FTC robot controller master, you have an FTC robot controller, and you have the team code. You want to make sure it looks like that. And so you want to open up this folder right here. Press OK. You give it a second, and a cool tip is sometimes if you look here at the bottom, there's like a progress bar. So something's not loading, or something's not working, or maybe your code isn't being highlighted for some reason. It's usually something that's a process that's happening here. So maybe you might say like it's indexing or it's building or something like that. And usually you just want to wait until it's finished and there's nothing here. You can also check out the event log. So the event log might have some useful information, but we'll first start with the window layout. So top left, lots of tools and options. So you can see you have all these file, edit, view, navigate, code, all these tools up here and tools. And if you look at something like Google Slides, it's very similar. And in the top right, you also have some action stuff. So if you look at Google Slides, there's some actions, right? So you can open comment history, you can present to a meeting, you can present. And just like in Google Slides, you have actions here. So you can make your project, you can run team code, you can do debugging. And yeah, so keep on going. So just below, you have the file tab bar. So just below all this, you have the file tab bar. And this is where usually, if you open up a bunch of files, that's where they'll show up. So let's just open up some files. Let's open up, let's say, some sample code. Let's open the hardware push file. You can see that it's up here. And here's the path file. So there you go. And then readme. And yeah. Let's see, why do we have an error? And so I guess another tip is, why do we have another tip is sometimes you see something that actually if sometimes if you see something that's red and you kind of know it shouldn't be red, that might be sometimes because you haven't there's been an issue with kind of detecting all the classes and files in your project. So you can do something like invalidate caches and restart, and this should make it fix. Oh, so that was a bit fast, but file, and then you just go to invalidate caches and click the invalidate and restart. And hopefully when you do that, it should go away, the red lines. Sometimes it's just your code poorly, has a mistake, but sometimes it's just kind of bugged out. So you can see the scanning files, indexing, there's stuff that's happening here. And you can see the progress bar. You might want to make it load, but we can keep on going with just like the general structure, because we can wait for that. Okay, so there was the file tab bar. So you can see here's the file tab bar. There's also the project structure on the left. So you might have noticed the project structure. If you close it and you open it, there should be a project structure right here. However, we're indexing, so we'll just give it a second. Yeah. The bottom is the terminal output and errors. So if we go to the bottom of our Android Studio, you can see that there's a terminal, right? And this is where you can run some commands. And we'll actually be running commands. There's the build, and you can see that the build's happening right now. There's a to-do if you may have any to-dos on your files. And so yeah, there's a couple useful tools here at the bottom. Mainly it's just terminal and build. Okay, and then finally we have finally we have this issue called Gradle projects failed, and someone actually notified us about this when they're setting it up, and we actually also had this issue. So sometimes you might see up here, instead of saying this, it'll say something along the lines of Gradle project sync failed or something, or and there might just be an error. And when you try running your code, there might also be an error. And so what you usually want to do is you'll click on, there should be some button to, why is this? But there should be, so it's like, it might be a blue highlight, and then there'll be like a button to open up the build view or something like that, and I'll open this up, and then it'll look something like this, and you want to click on the bottom one, the very bottom one here, failed to install, blah, 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 and then it'll open up a panel here on this kind of terminal side. And so you click on this, and there should be like a blue underlined text that says install missing SDKs or something like that. You just click on that, you go like through a process, panel will open up, like next, and then it install, and you should be okay. If you guys have any issues with that, you can contact us or our team, but or just leave a comment or something. But yeah, let's see. Why does this? This is really interesting. We'll just ignore it for now. But yeah, I think we can just go ahead and delete it. Oh wait, I think it's. Oh, okay, never mind. Okay, yeah, let's just not worry about that. Okay, let's keep on going. So we'll close these files. But that was the tab bar. So here's, and let's go ahead and go to the next time. Okay, so setting up a file to learn and practice. And this is basically our hello. So we're going to ignore the FTC part of Java first, and we're first just going to learn the basics of Java. So first we want to kind of, learn the syntax, the semantics, all that kind of stuff. And so we're first going to make the file. So we're going to open up the project structure. So if this is closed, you're going to open it up. You want to go to your team code. If your code doesn't look like this and you have to open up your FTC robot controller, that's probably because you have that Gradle issue and you want to follow the Gradle issue. So we just talked about that maybe like a minute ago, so you can skip back into the video. And so if we open up our team code, this is where we can open up our Java, and this is where we want to be writing all our team code. And so first we can create a file, right click, create new, and then let's go ahead and create new Java class. And new Java class is usually the classes you'll be on creating. You can also be creating like these, but we'll talk about, we're just gonna worry about the class right now. So class is kind of our starting point. So we can call this our first class. So this is our first class. You can notice that it's a .java file. And we can go ahead and our task is to print hello world to the system. So you can just mostly ignore all this terminology for now. But if we do public static void main and string brackets and then args, and finish it off with some braces, and we do system.out.println, and then whatever you want to put in your whatever you want to print, you type in quotes in here. So you can print hello world, and then exclamation mark. And then we have to always end off these statements, most statements that basically any statement that you don't end with a curly brace, right? And you want to end it off with a semicolon. So the thing about Energy Studio is it automatically saves. And if we want to just run just this first file, what we can do is we can open up a terminal, right? And so what we can do is right click. If we click terminal here, it might open up to, this is the directory that we're working in. So you can tell that we're working in the FTC robot controller master folder, but we want to actually be working inside this team code folder. So what we can do is you can actually right click on the team code folder and you click open in terminal. And go ahead and there's also like a tab system here. You can tell that this one is actually in the team code now, and this one's kind of, oh, we just closed it, but the other one was just in FTC robot controller master. So we can run this file by typing Java. And by the way, if you haven't had Java installed, you should check out the other video, but you can check out if your Java is installed, running Java-version, and it should give you the version and tell you some information. If this doesn't show anything and gives you an error, that means you probably have to install Java. You can check out the previous video, but basically what you just do is you just go online, you just drop JDK download, and you just go to the downloads, and then you click download. Oh, then you scroll down, whatever version you need. So this might be the Windows EXE version. Accept it. You click download and you go through the setup. Right. But we're going to assume that you guys already have that done. And so here we can run Java and then our file name. So first class and then first class. And you can see there's error first class.java. You can see that when we run Java first class.java, it prints out hello world and successfully made our hello world program. Okay, so now, yeah, that's running the program with the terminal. And let's go ahead to begin the actual programming in syntax. Semantics is basically, you can think of syntax as being like grammatically correct in English. So you can imagine correct syntax in English is saying something like I am 17, right? Incorrect syntax could maybe be something like I are 17. And so, or it could be something like she has an apple, versus incorrect syntax, which is she have an apple. And so that's kind of the syntax. Syntax is like the grammatical part. And so for Java, that's like the actual, you need to put a parentheses between something, or you need to end a statement with a semicolon, or there should be 3 arguments in something in a for loop. But that's like the actual syntax. Semantics, however, is the meaning. So you can imagine semantics, correct semantics might be something like the light shines green. And that's possible, right? Light could shine green, maybe you put a filter on it. Incorrect semantics could be something like the light shines smelly. How does a light shine smelly, right? It doesn't make sense. And so semantics is more behind the meaning of a language. And so for programming, it's when you put something, it should be able to make logical sense. It should follow some kind of order. And that's the semantics part. And so something like the light shines smelly it's grammatically, it's syntactically correct, but it's not semantically correct. Because how does a light shine smelly? If anyone knows a light that shines smelly, please let me know. All right, so table of contents, I'm going to be going over variables, conditionals, for while loops, arrays and ArrayLists, classes and methods, parameters and returns, which should actually just be under this. So let's edit that real quickly. So we can just make them parameters and returns. And then we'll talk about debugging, code formatting, best practices, and we'll do some conceptual understanding of inheritance, polymorphism, encapsulation, and abstraction. And this by no means is a comprehensive crash course or a comprehensive lesson on all of Java. There's a lot more to this, but this is kind of just the fundamental knowledge that hopefully if you understand this, we'll be able to do some FTC programming, or at least start with some basic program. And so first part, variables. So what are variables? Variables, they store data or information. You can imagine they're quite similar to what you learned in algebra, if you've ever taken an algebra class. And so you can think of something like y equals x squared or a equals prt. And so you can imagine x as a variable. You put in something to x, you square it, and you get your y output variable. Or you might do something like a equals prt. So if you ever learned about compound interest, that's kind of where the formula comes from. And so you put something into your p, you put something to r and t, and you get an a. And you can think of these as variables like algebra, but you can also realize that constants like pi or e or I, they are also variables because they hold a certain value. So pi, when you think of pi, it's correlated, it stores the data, its information is the fact that pi is the number, irrational number, 3.1415, and so on. And you can think of E as also another one with 2.71, so on, and I as square root of -1. So these constants also are variables in the sense that they store data information. Something to talk about in Java is that it's statically typed. So when you want to create variables, they often have to be, you always have to tell Java what kind of variable you're creating. So the kinds of variables that you can create are int, double, char, boolean, long, short, byte, float. And so we don't really care about these, but it's not that often that you use these last four, but int is any whole number. It could be negative, it could be positive, it could be 0. It just has to be a whole number. Double is a decimal, so it can be negative, it can be positive. Double also can, it has decimal points. And then character or char is just a single letter, one letter. So it might be A, B, 5, 2, a question mark, that could also work. Yeah, maybe it could be capital Z, lowercase c. And Boolean. Boolean is a kind of variable that can only have 2 states. So the first state is true, and the second state is false. So it can only be true or false. And this comes particularly useful when we're doing stuff like conditionals, where you're going to tell your program to do something if it's one condition, and to do another thing if it's another condition, or don't do anything at all. And the others, long, short, byte, float, those are also just all numbers. Long is a longer version of int, short is a shorter version of int, byte even shorter, and float is a floating point number, so it can also have decimals. And I believe it is shorter than double. Okay, so syntax for creating a variable, these kind of primitive types. And we'll talk about non-primitive types or reference types later, but for now, you can think of when you create a primitive type, you want to use type, name, value. And let's and here's an example, int my age equals 17. And you can, so here's your name, here's your type, and your type is always lowercase, and your value is 17. And so right here, the first part, type in name, let me turn on. Type in name is where you instantiate the variable, and then when you set it equal to something, that's where you declare it. And so you want to note that when you instantiate a variable, you're basically telling Java, here's take a piece of the memory that you're running and allocate it a certain number or a certain, basically you say, here's some memory allocated for your certain primitive type. So it might be int, that might be a double, that might be a character, it might be a boolean. All right. So we can go ahead and let's create a variable. So let's do int, well, let's just follow along the example. My age equals 17. And then we can also print out this variable by doing system.out.println, and you just put the variable. And if we go ahead and run that, you should be able to see 17 has been printed. Okay. So when you have these number variables, they have operations and they also have some restraints. So in Java, you can do some simple math like plus, minus, divide, and multiply, but you should be careful of the dangers of int and double. And so int and double, you can do multiplication. So you can do 17 times 5, or we can do 17. So if we run this, it was 85. And we can also do 17 plus 5, which will give us 22. Do 17 minus 5, and it'll give us 12. And so you can do 17 divided by 5. You might notice something special. When you do 17 divided by 5, you expect a decimal, something like 3.4, right? But instead, it only gives you 3. And this is a special thing with int. Since int can only hold full whole numbers, you basically, what happens is whatever's after the decimal cuts off. It doesn't round, it just cuts it off. So even if it's 18 divided by 5, which is 3.6, you would expect maybe it rounds to 4. But what happens is it just cuts it off. It just doesn't care about everything after the decimal and still returns 3. So if you wanted to do something like divide, you probably have to change this into a double. And another thing about when you do double in 18 divided by 5 is if you run it again, you expect, okay, this time it's a double, so it should be able to keep the decimal. The problem is what happens is order of operations. And so you might have an order of operations, which is like, you do have to do the multiplying before the adding or dividing before the subtracting. But that is still true in Java, but there's also other forms of orders of operation. So what first happens is if you do 18 divided by 5, which is an int divided by int, right? So this is an integer, this is an integer. And what happens is it does 18 divided by 5, 3.6, and it says, wait, this needs to be an integer. So it still cuts off the 0.6. Excuse me. And so it sets this equal to 3, and then it sets the double equal to 3, and then gives it 3.0. So how you can solve this problem is you can first just simply turn one of them into a double, and when you do a double divided by int, it gives you a double. You can even turn this one into a double. It doesn't matter. You just have to turn one into a double. And another kind of way you can do this is you can cast it. So let's say you do 18 divided by 5. You can cast, or you can, and when you cast, you can imagine it's like kind of synonymous to transform. You can transform one of the values into a double. So if you do parentheses double, you cast this 18 into a double, and it turns it into 3.6. You can also do the casting with the last variable. So you do the last variable, and you can, there you go, we get 3.6 again. And so, yeah, so that's plus, minus, divide, multiply, changes int. Doubles and can have slight inaccuracy sometimes. So I think just be careful of that. So if you do something like double divided by 3, you do double. And that's 3 times 3 divided by 3 times 3 divided by 3 times 3 divided by 3. You might get a slight inaccuracy. And so you can notice it's 2.3333. And it should be all threes all the way across, right? But then there's a 5 here. And that's the slight inaccuracy that we talked about. So it's very, very slight, but it's just good to know. You said this divided by 7 divided by 3 though. Generally accurate. So there. Oh, it's actually still not accurate. So still got 5 there. And so that's because of kind of just the nature of Java. Right. Yeah, and let's also talk, so that's order of operations. Let's see. Okay, let's also quickly talk about some other things you can do. So let's say you wanted to have a variable called my age and set it equal to 17. And let's say you want to add 5. So if you wanted to add 5 to 0, well, you might have to do it like this, right? My age equals my age plus 5. But this is actually pretty long to write. And so we can do is there's a shorthand version. We can do just 2 plus equals 5. And it makes it quick and easy. If you want to increment by 1, you would do my age plus plus, and that adds, increments it by 1, so adds 1 to it. If you want to decrement by 1, you would minus minus. And you can see how it's 17, and then you add 5, 22, and do it the shorthand way, 27, and 27 plus 1, 28, 28 minus 1, 27. And you can do this for basically everything. Plus equal, minus equal, divide equal, and what else? Plus equal, minus equal, divide equals, times equals. Okay. And so, but you can't do it like, you can't do this. That doesn't work. But you can't do this. Yep. Double slash is actually just a comment. And I'll talk about comments later. And yeah, it's basically it for number variables and primitive types. So now we're going to go ahead and talk about reference variables or non-primitive types. And in contrast to primitive variables, instead of saying a primitive variable which says, okay, we create this integer called my age, and right in that my age, we put a memory slot, put number. Instead, for reference types, they point to a spot in memory because it's not that easy to store. So you can imagine if you have maybe an object, a dog object, and some properties like a name and an age, instead of having just a memory stored and like, right there, it's actually the variable, all it does is store a reference pointer to where a memory location where it's the object is actually located. And so for so for a lot of objects, this is the point of object-oriented programming. This is what happens, and for all objects, but basically objects is a big part of object-oriented programming. That's what I'm saying. And so you can have objects in your own classes or external classes, and when you're creating them, you want to use the syntax type, name equals new, type, and then parentheses. And when we want to pass in some information, some parameters or some arguments, that's where we can put information. So you can imagine, for example, you have a person object, and its name is Bobby, right? The variable name is Bobby, and it's equal to a new person. And the new person takes in the arguments of probably Bobby, which is its name, and maybe its age, which is 18. And so a notable mention is string, which actually, since it's used so often, and string is actually just like a collection of characters or chars, they've made it easier to create a string. And so we can go ahead and create our own string here. Heading, we'll just delete this. We can create our own string, and let's say my name, and then we can put equal to Daniel. And so there you go. We created a string. We didn't have to do. You can notice that it's capital compared to something like an age, right? So int my age equals 17. Int is lowercase. If you try capitalizing it, it would not work. See? Or if you tried lowercase and string, that would not work either. So you can see that it's uppercase, and then instead of using the format where it's person Bobby equals new person Bobby 18, they simplified it. So you can create it like this too. You can still follow the format, but yeah, let's change the variable other name. You can see that it's grayed out because we're not using it, but it's just we can system.out.println line to actually use it. But you can see that how these produce, they do the same thing, but this is a lot simpler. And there you go. Yep. You can kind of see, yeah. So we'll go ahead and keep on going. So quick side note on enums. So enums is a special kind of class, but it's kind of like a variable where you can only choose a certain, there's only certain values you can choose. So you can imagine if we created a new and then class, but instead we actually did an enum, and we do like something like stoplight colors. A stoplight color enum can basically, you can think of it as kind of a variable that's restrained. And so what would you want to, what colors would a stoplight colors have? It could only be green, right? Red, and green, yellow, or red. And usually there's a naming convention. So you can notice for something like a variable, you want to start off with a lowercase first word, and every word after would be uppercase. But for something like enum, you want them all capitalized. And so this stoplight colors enum only has three options: green, yellow, and red. Because I have never seen a stoplight color that had been any other color. So if you ever like see a blue stoplight, yeah, let me know. It'd be interesting in taking a look at it. And so it should be already imported, the stoplight colors, because we can use it because we have this package. This package allows us to basically use any enums or classes or anything like interfaces even in this package. And so if we do something like stoplight colors, we can create stoplight colors, right? And then that's the type. And let's call it my favorite color equals stoplight colors dot, and we see green, red, yellow. And let's go ahead and choose green because who doesn't like a green stoplight? And so we're going to do that, and we can do system.out.println, and then my favorite color. And then I'm pretty sure we're going to have to actually compile. We're going to have to, we can go ahead and just run here. So let's run this instead of doing that. So if we run this and we build it, so we click over here and we ran it, still have build failed exception. Okay, this is probably because this is not actual FTC SDK code. This is just like a random file that we're using. How about we try? Let's just try running in the terminal. So we'll have this might give us an error as well. Okay, let's try compiling this. What if we tried compiling this one first? Okay, and then we try compiling this one. It says it's using it. I think this is just a. So, um, okay, this is okay. So since we're kind of working in the FTC SDK, usually you'll have like op modes and push bots and stuff like that. You won't have like actual main methods and things like that. And so you can just trust that if we ran this on a regular compiler, like if we're working on just IntelliJ, that this would compile and it would print green. But is there any way? Maybe I'll pull up another. Let's see. Because this is usually, I think this is because we're using another file. What if we just, okay, we'll just nest this enum in here, and then I think we should be okay. And so usually you want separate files, but just for the sake of this, we'll delete this one and put it in here, and then if we run it again, Java first class dot. Let's see. Let's just clear Java. Not even think that anymore. Okay, we can do Java first class dot Java. Okay, and there you go, print screen. So we actually put this enum inside this class, but usually they're separate classes. All right, conditionals. So conditionals are basically branching code into different situations. And so conditional can be like if, else, if, or else statement. So for example, you can have something like, let's go over the syntax first. And so it can be something like if condition one, else if condition two, else this. So condition one, condition two, they have to be Booleans. And so there's some special things about them. So you have not, and, or. And there's also some comparisons you can do between like numbers greater than, equal to, less than, or less than, or equal to, or the equals. And this is for just primitives. And we'll talk about note for non-primitives. And so let's just go ahead and create some examples. So the first one we can do is if, let's say, I'll create a Boolean that's called hungry. And let's set it equal to true. So if hungry, right? Then we can create curly braces, and then let's just system.out.println I'm hungry. I'm hungry. And semicolon. And then else, if you're not hungry, then you can put system.out.println I'm not hungry. And then make sure to end it off with semicolon. And so based on this hungry variable, so it's true or false. And so we can see it prints I'm hungry since when it's true, and when it's false, it's false. Prints I'm not hungry. And so we could do something else. Let's say we have a Boolean, now we advance, right? So let's do int hunger level. And let's say equal to 5. And we could do another if statement. So if hunger level is greater than 10, or let's say it's a range from 1 to 10. So let's add a comment just for maybe people to realize. Range from what? Range is from 1 to 10. So if hunger level is, let's say, greater than 5, then use system.out. I'm super hungry. This actually changes to 10, or greater than 8. So I'm super hungry. And then else if hunger level is greater than 5, we can put system.out.println I'm hungry. And then finally, we can put else system.out. So if it's not greater than 8, it's not greater than 5, then do system.out.println I'm not hungry. And so let's delete this one because it might confuse us. And so we can go ahead and run it. And it says I'm not hungry because if 5 is not greater than 8 and 5 is also not greater than 5. And so it prints a very final sign. But if we do something like greater than or equal to, you can see that it prints out I'm hungry. And so that's if statements, but let's talk about, so that's less than, greater than or equal to. You can kind of get the idea of these. And say we can also do something like if, we can do something like else, we can do something like greater than, right? And then just greater than. And we can do something like else if hunger level is equal to 5, right? And then let's make this some nice formatting. It's okay. And then make sure it looks nice. If it's equal to 5, then we'll do system.print.println I'm in the middle. And so see that it prints I'm in the middle because it's equal to 5. A special note about these equal statements though are that they have to be between primitive types. If you did something like a non-primitive type, reference type, something like a string. So we can do something like string my name equals Daniel. If we can't do something like if my name equals Daniel, and this is because the thing about reference types is they point to a memory. So when you do equal equal, you're checking if this my name variable points to the same memory spot as this quote Daniel. And so this won't actually work because they point at different memory spots. And so if we try printing this out, this won't actually print because they don't, wait, other line equals. Oh, wait, okay. Let's try it. Okay. Let's use string. So this actually does work, but let's say you have two variables. And this is kind of mostly the case. Second name equals Daniel. And then if you did my name equals second name. So even though they have the same content, this, I'm in the, maybe, maybe, maybe the Android student is actually so smart enough to automatically convert this dot equals. So it should be like this, all right? My name dot equals second name. I'm not too sure what it's actually printing. I don't know one equals. Well, I guess more actions. Let's see. More actions. It actually does print. But usually when you do dot equal equal, it should not be comparing two strings. I guess IntelliJ tries to understand what you're doing. They know that you're trying to compare two strings, and so they automatically convert it to dot equals for you. But dot equals is usually what you do to compare two objects. But yeah, so for regular primitive like types like the equal equal, you want to use equal, or regular primitive types, you want to use equal equal. But for more complicated objects, you want to use dot equals method that usually should be implemented in the object. It's actually really interesting. My name equals second name, and it somehow still works. More actions. Well, let's just keep on going. You always want to use, even though for some reason in Android Studio works, it might not. It's probably not going to work other places. And so, yeah, let's just keep on going. So, for and while loops. So, for and while loops, they're used for iteration, and iteration is to perform or utter repeatedly, as a definition by Google. And so, for loops, they loop from a start condition to an end condition and have a certain iteration condition, so step. And we'll also talk about enhanced for loop. And for while loop, it's while you just loop while condition is true. And so they're usually situational use. So for a for loop, you might want to use it something like moving a square because you want to move forward and turn right 4 times to make a square. And for something like a running a teleop, you want to use a while loop. So while your op mode is active, you keep on doing something. You keep on running the teleop. And so you can keep on iterating through the teleop. And so for for loop, it looks like this, and for while it looks like that. Let's go ahead and make an example. So 4, and usually we do something like int I equals 0. So you start with I equals 0. I is less than 4, and so that'll run, and you do I plus plus. And so this will run 4 times. It'll run when I is 0, y is I is 1, 2, and 3. So you can do system dot out dot print line. And even if you're not using this I, you actually, this is how you would do it for something like looping through 4 times. And so you can see 0, 1, 2, 3 per time. But maybe you just wanted to print something out 4 times, and you do it the same way. So even though you're not using I, you could kind of just do it 4 times and do Daniel. And let's say you can also change this condition, so it doesn't have to be I plus plus the increment. You can do something like I plus equals 2, so it'd be 0 and 2, and it'll only print out twice. And yeah, that's about it. Let's see. That's a for loop for you. And you can do also enhanced for loops that we'll be showing later, but it's the basic condition. You can also nest for loops. You can do for and I equals, or j, because you already use I, equals 0, j is less than 5, j plus plus, and then you could do something like system dot out print line. Do I plus a space and then plus j, because you don't want to just be adding I and j together. So you can see if you run this, you can see it starts with I equals 0, and then so it runs this loop, and it's at 0, and then it runs this loop 5 times, so 0, 0, 1, 0, 2, 0, 3, 0, 4. And then after this has been done run 5 times, then it goes back to this outer loop. It increments it by 2, so now it's 2, and I do 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. And then increments again, right? But then what happens is now I is 4, and I 4 is not less than 4, so then it stops. All right, while loops. So something like while loop can be like uh, winnings equals 0. and then int number equals 0. And so every time the number, so every time we're going to randomly generate a number, and every time the number is not, let's say, while number does not equal, so we saw equal, while number does not equal 5, we're going to add 1 to our winnings. And then we're going to set number equal to math. So there's a math and then dot random, right? And so math dot random, and this will generate a number of, this will actually generate a decimal from 0 to 1. And we're going to want to multiply that by 10. So we have range from 0 to 10. And then since this, you can see if you hover over the error, this is decimal, you're trying to set it equals to int. So we're going to want to cast this to an int. And we want to make sure we cast the whole thing. And so we can run this. And since we're generating a random number, and then at the very end, let's print out our winnings. You can see that this time our winning was just 4. So we got 4 winnings. Now it's 2. And since this is because we're generating random numbers, it changes every time. So 3, 2, 6, 3, 19. Wow. Wow, 19 numbers were generated before a 5. That's pretty crazy. But yeah, you get the idea. So that's while loops, that's for loops. Excuse my God. Arrays and array lists. So arrays and array lists, basically they store information for you. So and it's in a certain order and it's a list. And so you can imagine maybe you have a phone book, and a phone book could be an array of a bunch of phone numbers. And so for an array, it's limited in size. You fix memory allocation, and it must be set up for types. So limited size means you can only, if you say it's 5 elements, you only can have 5 elements. You can't go bigger, even if you wanted to add it. It also means that the memory is fixed, so you only have a certain amount of memory. And it also must be statically typed, which means if you create a variable, when you create an array, you have to tell them is int, it's a double, it's an array of strings or doubles or ints, and whatever you want to make it type. And then array list, however, is unlimited size. And so if you can add, let's say you have 5 elements, you can add a 6th element. And it can also be dynamically typed, which means you don't actually have to tell them what kind of variable you're holding in the first place. And that's a kind of a neat thing. And so let's do some examples. And so also a note about array lists, they could be reference type only. Okay, but let's create an array first. So let's create an array of strings. So let's do array. We don't do array. We do, that's wrong. We do type name equals new type. So string, let's say friends, and then equals new string. And also make sure into the brackets the elements in array. New string, and then we want to put the size in here. So let's say I have 5 friends. And so you can set friends. And so let's say we set 5 friends, right? And then what we can do is we want to set, and so the thing about arrays in Java is that there's 0 indexed. So usually in normal life, you count, right? So 1, 2, 3, 4. But in Java, or let's say you have 4 bottles, right? You count first bottle, second bottle, third bottle, fourth bottle. You're 1 indexing. In Java, however, the first item is actually 0. So if we wanted to access the first item, friends 0, we can set that equal to, let's just set it to Bobby. So we have Bobby, and then we can do system dot print line friends 0, and we'll be able to see that we have Bobby. Let's say we try accessing the first element. We haven't assigned the first element yet, so it'll just be null, or it'll be there's nothing there. But we can, let's say we want to assign all my friends at the same time. We can do something like no brackets or no size, and then we just tell them my friends are Bobby, Joe, Bob, and Joey. And so we can do something like, let's say we want to print out all of them, right? We could do something simple or trivial, like we do system.out.println friend 0, and then we can like copy paste it 4 times, and then 1, 2, 3. And this would make the, it would do the job, right? we have four system.out.printlines. This is very redundant code. So instead, we could do a for loop and do something like for int I equals 0, I is less than 4, I plus plus. And so now we do system.out.println and then friends and then brackets to access, and we can put, instead of 1, 2, 3, 4, we just put I. And you can see that this now prints out all of them still, but it's much more concise code, or much more less redundant code. And so you might think, is there any way to make this even simpler? And yes, there is. If you want to loop through a for list, there's an enhanced for loop. So we can do something like for string. So you want to do string names. So instead of doing int I, you do the actual data type node. So instead of int I equals 0 and you access it, you just do string name and then in whatever array you want to do. So string name friends. And then we do system.out.println name. And there you go. It do the exact same thing. And it's even simpler now. And a note about these for enhanced for loops though is you can only access the variable, you can't actually change it. So if you wanted to set this name equals, let's say all into Bobby, this would not actually work. So it might show here, right? So it might show that name equals Bobby here. But then if we run it again, if we run this for loop again, and we don't do set Bobby and print out the name, this actually has not saved the change to the actual array. And you can see that it's still Bobby, Joe, Bob, Joey. Okay. So it doesn't actually change the values. So it might change the value temporarily in this enhanced for loop. Maybe do that, but you wouldn't change it permanently inside this actual array. Okay, let's do array list now. So let's do array lists. So this time we actually do type array list, and then we put the type here. Let's put, how about we put integer? And so you kind of actually put int. These all have to be reference types. So integer is basically the reference version of array list. And then let's also import this. Yeah, so we might have to import it. So go up here, import array list. Array integer equals phone numbers equals new array list, and then you would want to put integer here, and then leave the parentheses blank. Then you want to add phone numbers, right? So you want to add a phone number. So you do phone numbers dot add. So that's how you would add a phone number. So for something like this, you might just be assigning it, right? You might just be doing something like friends 1 equal Joe Bob. But for this one, you're going to do dot add, and then you'd be adding an integer. So let's do phone number 626 62123 4 5 6 7, something like that. And then let's see what's there. Okay, this number is actually too big. Okay, let's make it bigger. How do you make a number bigger, you might ask? And that's why something like long might help. So long. Still might be too big. Okay. Double. It's pretty big. Oh, it's still too long. Okay. What is bigger than long? Let's just Google it. Google can always help. Insert or bigger than integer. Okay, well, there's big integer, but that seems like we have to import something. Use long type. Well, we did use long type, and it's still too long. I think this is might be just. Let's see what happens if we run it. Okay, so that's what do I do? Let's do long. Okay, well, okay, let's just pretend. Let's just control Z all this. Turn it back into integers. Let's just add. How about we just add like 1, 2, 3, 4, 5, 6, 7. Let's say we already know the area code. Okay. So that's how you add it. If you want to remove it, you do phone numbers dot remove, and then you can either type in the object. So you can either type in 1, 2, 4, 6, 7, right? But I have to probably, okay, so this would remove, you'd have to cast it into the object first, and this would remove that integer. Let's actually add some more first. Let's add one. Okay. And so if we wanted to print this out, we could actually just do, and so for something like array, if you try doing system.out.println friends, it just actually print out the memory location since it's a reference. For something like system.out.println phone numbers, it actually has a toString method. And so basically it would be print out a string representation. So you can see how this prints out just a method, but this prints out the actual array, which is just 111 because we removed this one. You could also remove it by index. So when you add, you always add to n. So this is the 0th index, this is the first index. So we remove the first index, it'll only print out the 0th index, which is 1, 2, 3, 4, 5, 6, 7. And that's add, remove. You'd also do phone numbers dot. If you want to retrieve a value, you could do phone numbers dot. Let's remove the remove. And then do phone numbers dot get, and then we could put the index. So let's say we want to get the very, very first element, 0th element. Then you get 1, 2, 3, 4, 5, 6, 7. And if you want to get the same one, you just get 1. And so add, remove, and get. There's more methods. You can always definitely Google them, but those are kind of just the basic ones. And let's see. So that's about it for array and ArrayLists. And yeah, okay. Let's see. What do we have? So classes and methods. We have some debugging, conceptual understanding, and that'll be about it. Okay. So classes and methods. So classes are basically the basic. This is a fundamental part of object-oriented programming because classes allow you to. It's basically a blueprint that allows you to create objects. So you can imagine, helps you. If you had a dog class, you can create a bunch of dogs. And let's go ahead and do that. So classes contain constructors, methods, variables, and can even nest their own classes. And we'll talk about these keywords later. And so hopefully you'll be able to understand what all this public class stuff is. So let's create a new file. We're going to call it the dog class. And so this dog class can help us create dogs. So what's the first thing about a dog? So we had each class, each object has its own properties, and classes help you kind of establish those properties. And so you might have a dog class, and let's say each dog has a name. So we actually want to make the name. We usually want to make these properties private. And this is a part of Java's kind of encapsulation and abstraction part, where you want to make sure that they don't have direct access, but they only access it through certain methods. So they don't have, people who go on your program. They only need to know how, okay, if I want to get something, I can do that. And it also prevents, it prevents excess information. You want to let people know only what they need to know, so they don't have to know everything to understand how something works. So private string, let's say name, right? And we don't know what their name is yet because we haven't created it yet. So when they first create it, when we first construct the object, that's when we'll have a constructor and we'll assign it. Let's say we have an age too, int age, and then private string, or let's do private Boolean is hungry. And so we have these properties now, but we actually have to kind of, when you create an object, you want to make sure that, you can actually set these properties. And so we can create a constructor. So when you first create an object, you run its constructor, and that's this parentheses thing right here. So this is where the constructor happens, where you can pass in details. And so let's do public dog, and then let's pass in, so you can pass in, first you can pass in nothing. Let's say you pass in nothing. If you pass in nothing, we can just set name equal to, let's just set it to NA, so it doesn't have a name. If you don't set it, it'll just be null. The actual value will be null. So it means that there's nothing that's been assigned. And null is different than string or anything. It's just actually just nothing. And it's a special kind of data type, null. And then let's set age equal to 0, although it's already default to 0 when you have an int. And then we can put is hungry. Let's just set it equal to false. And so that's how you create it with. And so let's actually run. Okay, so this public main string, this public static void main string args is when you can actually, where like you can actually run stuff, you can create objects. And so let's create as our own public static void main string arg in here. And so what this means is we'll talk about the static keyword later, but this static means you don't have to actually create an object to run this method. And then the main is a special keyword that says when you run this Java file, it will look to see if there's a main file and it'll run that will actually execute whatever in here. And then this string args is if you pass in any arguments when you're running it. So you can imagine if we pass in an argument called, let's actually do that. We pass in an argument called slowly, and then we did a check. If args 0, right? If arg 0, so the very first arg, this is the very first arg. If arg 0 does not equal null, so if it's not null, and args 0 equals or dot equals slowly, since it's a string, we can just print out slowly. And so you can see that when we run java dog.java slowly, it'll print out slowly and prints it out. And let's say we did something like, let's say we didn't put in like ASDF, then it won't print it out. But if we did something like, and we put in no arguments, it wouldn't print it. Oh, actually, okay, index 0 out of length. This is the wrong check, sorry. You want to make sure that args.length is equal to 1. So if it's not equal to 1, then basically what happens is, oh, we didn't even talk about this actually. We talked about the not. But if args, so this makes sure that this command has to be true and this command has to be true. And so this is the and. Something else might be like or. So or doesn't really make sense in this case. But let's say if this one equals slowly or args 0 dot equals, and let's say they misspelled, like put capital, so slowly. So either way, it works. And so if this is true and one of these are true, then I'll print slowly. And the neat thing about and is if the first one's false, then it doesn't run the rest. It just automatically knows there's no way that this can be true because the first one's false. And they have to both be true. And so it just automatically doesn't check this. And then it prevents errors like these where it doesn't actually even check arg 0. So nothing happens. But if we do something like slowly again, then I'll print out slowly. So that's the args, and that's the and that's the or. There's also the not. The not is pretty simple. So if you had a boolean is hungry, and if you do not is hungry, then actually a thing about static is you don't have to create an object to run it, but also can't access these non-static object variables. And so you can create a static object, maybe a static variable. Maybe let's call it private static total dogs equals 0, right? And so total dogs should not be attributed to a single dog because it's total dogs. And so private static int total dogs. And let's set this to blank. And then every time we create a dog, right? Every time we create a dog, we do total dogs plus plus. And so it adds a dog. And so you can imagine you could print out something like system.out.println dogs, total dogs. And even though this is static, since this is static, you can access it. If this wasn't static, then it'd give you an error. But since it is static and because this method is static, it can only access static variables. So if this was not static, it could not access it. But you can see that something like total dogs, so regardless of if this is static or not, it can always access it because this method, this constructor is not static. All constructors, by the way, are not static. But yeah, so total dogs. So let's make it a static and total dogs. And we also print out does total print system.print out total dogs equals 0, right? And I'll print out true. And if we do not equal 0, let's do not total dogs. It's not equal to 0. You would actually just, so this, you can just imagine this flips it for you. So it flips it to false, but something like this, you'd actually probably just do something that's not equal to 0. And so this is also print false. And this is how you'd want to do it. But okay, back to the main point. So this is Static means you don't need an object. Void, we'll talk about that. Main is the thing that looks like when you first run the Java file with this class, it'll look to run the main method. And args is the stuff you can pass into the command line. Okay, back to constructors. So we created this constructor called, and this takes in nothing, and it creates, it says the name is NA, it says age equals 0, it says is hungry to false, and it says total dogs, and it adds 1 because you just created a dog. We can also create another constructor. Let's create one that actually takes in everything. So it takes in string name, it takes in an int age, and it takes in a boolean is hungry. And so what you want to do is you want to set name equal to name, right? And then age equal to age, and then is hungry equal to is hungry. And you set this variable, this name equal to this name, and this age equal to this age, and so on, or this age. But the thing about this is what actually happens is since your parameters, since the values you pass in are actually the same name, it's just setting it equal to self. So to solve this problem, when you want to pass in a constructor and you have the variable, the parameters is the same name as your actual properties, your actual instance variables, what you do to do this dot name equals name. So this object. And so this is a special keyword. And so it set this new dog you're creating, and so this dot name actually refers to this, and then this name refers to this. And we also still want to add total dogs. And so let's go ahead and create. So this is Leon. Well, actually, we'll just leave this here. Let's just leave this one and create a new dog. So dog, let's create Bobby equals new dog. Name, let's put Bobby. Age, let's put 10. And is hungry, let's put true. And you can see that it works. But let's say if we left that argument, there's no constructor for this, so it gives us an error. And so let's just put in all 3 arguments. And so now we have this new dog. And then since we created a new dog and this total dog static variable got incremented, we do system.out.println, and then we're going to do dog.total dogs. And so that's how we access the static variable. If you try, oh, actually, we should probably make this public since this. Well, let's make it something that's easy to access. Just let's take the example. As you can see that it's 1 since we created a dog. But but yeah, if you try accessing something like dog.name, there's 2 things wrong. First of all, this is not static, so you can't access it through the class. And even if, so you would have to do something like Bobby.name, and Bobby.name, since this string is private, when you try accessing it, it give you, oh wait, Bobby.name. I don't know what's been up with this today, but Bobby.name is, oh, it's because this method is inside this actual class, you can still access it. But if you try doing this, so if we did it over here, so we did this over here, well, actually, I think you'd have compilation issues again because we didn't actually build the project. But you can see Bobby.name has a private access, so you can't actually access it. But since we're in this class, we can actually access it because our static one main method is actually in the class itself. But yeah, so private allows access, I think, yeah, so private allows, let's see, let's go. Private allows access in the class, but nowhere else. And so public allows everything, protected is a special kind. And if you don't put a modifier, so if you just left this blank, then it would be these conditions. It's blank. But let's put back on private. Okay. And so there's your constructors, there's your instance variables. We can also write, so here's your main. So this is kind of one of a kind method. We also run some other kind of methods. So let's say these variables are private, right? So let's say you want to actually access them. How do you do that? So you can write a public method that returns this name. So public, and then this return type, so you can see that this one's void, and constructors have no return type because you're just constructing an object. But public, and then you put string as a return type, and you put it as a get name. And this would put, and then you could return name. Or you can do this dot name. But when you do something like name, it actually automatically converts it to this dot name when you don't have this issue of conflicting variable names. So this dot name, we can do that, just do name. And then we can also do something like public Boolean is hungry. And then return is hungry. And so you notice it, if you have a return type of string and you don't return anything, it gives you an error because it says, hey, I'm expecting a return type of string. And if you, and so sometimes you don't want to return something, right? So sometimes you want to modify something. Let's do public, and then we want to modify it. So that's when we do void. If we don't want to return anything, do void. And let's say we want to set change is hungry. And then we want to pass in, well, what do we want to change is hungry to? And so let's put our Boolean condition. So this is a parameter we pass in. This can be called anything. I just decided to call it condition. You can call this Bob too, but that one would be very descriptive. So condition. And then we can set this dot is hungry, or we can just do is hungry equal to condition. And you don't have to return anything because you're just modifying something. And then you can also do something like public void change name, and then string name, and pass in the name you want to change it to. And since this is the same name, you have to do something like this dot name equals name. And there you go. And so those are your getters. These are your getters. And these are your setters. So you get something, you set something. And there's also sometimes maybe you just want to write a method that just does something, right? So maybe like public void bark. And this doesn't set anything, but maybe it just does system.out.println and then does this dot name, right? And then barks. Woof, woof. And so if you ran this, we could do something like Bobby, right? And then we first set the name. Let's change the name. Change name to Joe. And then we can do, so the variable is still called Bobby, but the name of instance variable within it has changed. We do Bobby.bark. It now uses Joe, and I don't know what it is here. Okay, Bobby.Joe. And then it's changed it to Joe Barks. Woof, woof. And so you can see that it's first Bobby, and then you change the name, and then Barks. All right, so that's classes and methods. So getter, setter, return parameters, constructors, and a final keyword. So final keyword is sometimes when you don't want to change something, right? So let's say you have a final keyword. So private final, let's say it's always alive. It's immortal. So private final Boolean alive equals true. And so when you try modifying this alive variable, you can't. It gives you an error. So cannot assign a value to a final variable. That's just final. Okay. And all right, we'll wrap it up here. So for debugging, you will usually want to do system.out.println. There's a little breakpoints. So you can set breakpoints. And this is more when you're running your actual teleops and everything. Basically, breakpoints help you debug. They stop at here. They can tell you information about the current variables that you have. And so you can add breakpoints by just clicking on the side and it'll be red line. And then, yeah, there's also the debug feature. And we'll be going more into that later, or you can just go explore your own. And so comments are good to tell people what your code is actually doing. And so you have the single line, so single line comment. You can also do a multi-line comment like that. So /*, multi-line. And then also when you want to do documentation, you do double asterisk, and then this is the convention for documentation. And so that's about it for comments. And code formatting and best practices, you can kind of just look at these links. I'll probably be sharing the slides. And then code formatting, so there's white space, tabbing, space between characters, those kind of things to make sure that your code looks nice and well formatted. You don't want them all on one line, or you don't want maybe the indentation to look really ugly. And so you don't want stuff like this, and you want to make it just readable. Legible, I guess, and then spacing between characters. So when you do something like a for loop, you want to make sure you have you want to have see, I deleted it. But for something like when you do set equals, you don't want to make it all tight and scrunched up. You got to make sure spaces so it's kind of readable, and you can take a look at the best practices. And then conceptual understanding. So this is purely just conceptual. This is more in depth into more of Java, but it's good to know about inheritance. So inheritance is basically the idea that you can create classes like an animal class, and the dog class extends the animal. So an animal, or let's say a pet class, for example. And so maybe the pet class, you have the name attribute and you have the get name attribute, and you can have multiple things that extend the animal class. It inherits the properties of the animal class. So you can have animal class or pet class, you have a cat and a dog, and since both cat and dog usually share a name and maybe the owner name, then you would put in animal and it'd be shared to the dog, cat, maybe even like hamster. And you can also override methods. So for something like maybe you have a uh, make noise method, right? And so the default noise for maybe a pet might be like, I don't know, woo, it might be like WOO, right? Just prints out WO. But for something like dog, you can override it to make a bark. And for cat, you can make it like purr. And for maybe a hamster or like a bird, it could be like chirp, right? And so you can override the methods. And polymorphism is the same idea as kind of inherit. It builds off inheritance, and it basically says you can create a variable that's type animal, but since create a variable that's type animal, but since dog extends animal and dog is animal, you can set that animal typed variable to an actual dog object. And that's pretty, it's more advanced, but I guess this is just exposing because we can't teach everything in like an hour or 2 hours. And encapsulation abstraction is basically the idea of showing only essential information of class object code, like the private methods, private instance variables, and only public methods. And then protects data access and it reduces code complexity. So when someone else wants to use your code, they only need to know these are the methods they need to use and so on. They don't know how need to know how all of your code works. And so, yeah, that makes it easier and that abstracts data away. And so it's like analogy is like using a car. If you drove a car, you should only really need to know how to turn the steering wheel, how to go faster, how to stop. And you shouldn't need to know how the car engine works or how all the mechanism works or the machinery and all that kind of stuff. All right, so project, this is completely optional assignment, but if you want to learn and explore more, I definitely recommend to, go hands-on and try to make something. Okay, so that's about it for today's lecture. It's actually pretty long. Thank you guys all for listening. If you have any questions, make sure to contact us at wolfcorprobotics12525@gmail.com. I'll also be sharing slides and the code that we wrote inside the presentation or inside the YouTube description. And so thank you all for watching and hope you guys keep on learning and stay safe.